Today we're going to be learning about box and whisker plots. This is also called a box plot, so you could hear it either way. This starts on page 599 in your textbook. You should have already created Cornell notes to take notes on this video as you watch. I want you to take notes just like you normally would if I were up in front of you teaching this lesson. Feel free to pause it at any point if you need to have more time to write something down, or go back and re-watch a certain part. If it doesn't make sense, go back, re-watch it. Hopefully it will make more sense the second time around. Alright, our main idea today is to display and interpret data in a box and whisker plot. Our new vocabulary, box and whisker plot. If you've never heard of it, a box and whisker plot uses a number line to show the distribution of a set of data by using 5 values. Now we're going to go over what these 5 values are in just a minute. Alright, so I need for you to write down the steps to construct a box and whisker plot. We already know how to find all of these values. That's what we've been doing the past few days. Okay? We've gone through, we found the median. We found the upper quartile, the lower quartile. We've figured out if there were outliers, and if there were, what they were. Now we're going to take that information and we're going to put it into a box plot. Okay? That way we can easily look at this plot and determine information about our data set. It's a lot easier to look at and figure out what we've got going on. So step 1, we're going to find the measures of variation. What we've been doing. Step 2, find any outliers. We've been doing that as well. Step number 3, draw a number line that includes the least and greatest numbers in the data. So we've got to look at this. Obviously, we're going to put it in order from least to greatest. We've got to see my number line must go at least to my smallest value and then at least reach to my largest value so that I can fit everything on the graph. Step 4. Mark the least value. That's the thing we have not gone over. The least value is also called the minimum, or the lower extreme is another name that we can use for that value. It's just the smallest number in the set. Our lower quartile, median, upper quartile, and then the greatest value, which is also known as the maximum or the upper extreme. 3 different names. Same thing we're talking about, just the largest number. Alright, so we're going to mark those above the number line with dots. Step 5, if an outlier exists, okay, we know that it doesn't always exist, but if it does, we're going to mark the outlier with an asterisk, basically with a star. And then the next number becomes the lowest value or the greatest value. So for instance, if my highest values in my data set were 20 and 21, if 21 was an outlier, then I could no longer use it as my greatest value. It could not be used as my maximum. Okay, so I would have to move my maximum to 20 instead of using 21, because 21 would have a star on it because it would be an outlier. Alright, step 6, once we've figured all that out, we're going to draw a box around the lower quartile, the median, and the upper quartile. I'll go through and show you exactly how to do that. But you're just going to draw vertical lines on those 3, and you're going to create the box. The last step is to connect the whiskers. So to draw straight lines from my box to my lowest value and to my greatest value. That creates the whiskers of my box and whisker plot. Alright, so we need to go ahead and look at an example. Okay, this example includes the numbers 4, 7, 5, 3, 9, 6, and 4. Our first step is going to be to put this in order from least to greatest. So in order, 3, 4, 4, 5, 6, 7, and 9. Alright, first thing we need is the median. Okay, the median. The median is going to be right in the middle, so that would be 5. Our upper quartile, 7. Remember, that's the middle of my upper section. My lower quartile would be 4. My IQR, 7 minus 4 is 3. Multiplying that by 1.5, we're going to get 4.5. Okay, now I need my upper limit. To find my upper limit, I take my upper quartile, which was 7, add 4.5, that special number, to it. All right, so that would give us a total of 11.5 as my upper value, my upper limit. And then for my lower limit, I'm going to take my lower quartile of 4 and subtract 4.5. So I have negative 0.5. All right, so looking at our values, we do not have anything greater than 11.5, so that one gets a no. And we have nothing less than negative 0.5. So no, we have no outliers. All right, so to create our box and whisker plot, we're pretty much ready. We do need to identify our min and our max, or our lowest value and our greatest value. So lowest value would be 3. It's my smallest number. And my greatest value would be 9. It's my largest number. So my number line has to go all the way from 3 to 9. So sketch you a number line. I'm going to start mine at 2. And it's going to go all the way to 10. Try to make yours as even as possible. Mine didn't really end up very even. All right, so to create this box and whisker plot, I'm going to put a vertical line at 5, which is the median, a vertical line at 7, the upper quartile, and a vertical line at 4, my lower quartile. Now, connecting these 3, I create the box for my box and whisker plot. All right, now I need to go to my least value, my lowest value, which is 3, put a dot, and draw my whisker to connect it. And then go to my greatest value of 9, put a dot, and connect it. Now I have created my box and whisker plot. All right, moving right along to our second example. Okay, in this example, we have the numbers 13, 12, 17, 10, 6, 11, and 14. So putting those in order from least to greatest, we have 6, 10, 11, 12, 13, 14, and 17. Finding our median. Our median would be 12. There are 7 numbers, so it's the 4th one. Our upper quartile would be 14. Lower quartile would be 10. IQR would be 4. 14 minus 10 times 1.5 gives us 6. My upper limit would be 14 plus 6, which is 20. Lower limit, 10 minus 6, which is 4. Do I have anything in my data set greater than 20? No. Do I have anything in my data set less than 4? No. So no outliers. Okay, my min value, or my lowest value, would be 6. My highest or greatest value would be 17. So this number line needs to go all the way from 6 to 17. All right, so draw your number line. All right, got my number line done. Now we are ready to actually graph this box and whisker plot. So the first thing, I need a vertical line at 12 for the median, a vertical line at 14 for the upper quartile, and a vertical line at 10 for the lower quartile. Connecting these three, I create my box. I need a dot at 6 for my lower value, connecting that with a whisker, and a dot at 17 for my greatest value, connecting that with a whisker. I have now created my box and whisker plot. Alright, box and whisker plots separate data into 4 parts. Important that you know that. Although the parts usually differ in length, each part contains 1/4 of the data. So each part of the box and whisker plot consists of 25% of the data. So the first whisker is 25%. The first box is 25%. The second box is 25%. And the second whisker is 25%. Even if there is an outlier. Okay, that last part all the way to the outlier would be your 25%. Now, it's always going to be 25%. Okay, so when we ask questions about this, which we'll do on the next slide, your answers are always either going to be 0, 25, 50, 75, or 100%. So think about quarters. When you hear of quartiles, it splits it into 4 quartiles. Think of quarters. All right, a long whisker or box indicates that the data has a greater range. That should be has. All right, so right here, the data may be spread out more. So the numbers they may have several numbers in between them. A short whisker or box indicates that the data has a lesser range. So those numbers may repeat. They're very, very close together. Okay, so that would make the box or whisker a lot shorter. Looking at this, we've got our box and whisker plot already on there. All right, we want to compare data between the median and the upper quartile and the data between the median and the lower quartile. Okay, so if I'm looking, here's my my data that's between the median and the upper quartile. In orange, this is the data between my median and the lower quartile. Now we can tell that between the median and the lower quartile, the data is a little bit more spread out. So that means from the median to the upper quartile, the data is closer together. All right, additional questions. What is the range? Looking at this, my largest value in this case would be 68. Minus my smallest value would be right here at 42. Okay, so 68 minus 42 would be 26. All right, are there any outliers? Looking at this picture, I can easily tell. Yes, I've got a star right there. Okay, so yes, there is an outlier. The outlier would be at 69. Which quartile shows the greatest spread of data? If we look, this whisker is longer than any of the other whiskers. Okay, that would be quartile 4. So quartile 4 is spread out the most. The last question, what percent of the data shows the average daily commute time is greater than 55 minutes? If we look in purple, 55 minutes is right here. That's the median. So what percent is greater? Well, quartile 3 is 25%, and quartile 4 is 25%. So 25 plus 25 gives me 50%. 50% is greater than 55. Okay, now I would like for you to complete page 171 in your workbook. When you finish this, come show me your notes as well as the workbook page.